Hi everyone, and welcome to another episode of Python 3 Crash Course. My name is Nick from Coffee Before Arch, and today we're going to move into a topic that's a little bit different than what we've gone over before. So previously we'd gone over a lot of ways of, the building blocks of how to solve a problem, but there also exists an area of programming that's very important, and it's how do we handle the cases where things don't go our way, where we run into problems and it's something that we can't necessarily control. This may be because we get some strange user input. We may be reading a file that's been corrupted or has something that we're not expecting, or maybe it's even bad data and we hit some corner case that will cause a problem. Let's say we're reading in data to do some kind of operation and we end up reading in something that would give us, say, a divide by zero error. And you may have run across this when you're programming, that whenever you say misspell something, or you maybe you do something like you divide by zero, you index a list of something that doesn't exist, you run into these exceptions. And it would be nice if our program didn't immediately crash. Sometimes we want to make it so, we can, figure out when these types of things happen, and then maybe we can recover. So instead of, if we ask the user for some input and they give us a bad input, instead of our program crashing and having to launch it again, maybe we want to, take that in, recognize that it was a bad input, and then ask the user again for another input. So that's just one case. And then there's also cases where we don't want to wait for an error. So what we talked about previously is mainly dealing with handling exceptions, so when things go bad. But if we can prevent things from going bad or getting to that point, we'd like to do that as well. And so we can do that with assertions, where we can exit a program early if we know something bad will happen. So instead of maybe a program running for an hour, many hours doing something, and then you find out at the end it's broken because, say, some function had a bad input, well, we can test the inputs ahead of time, and then we can make it so that we don't have to, wait until the very end to find out that it was bad. So let's go ahead and open up our example for today, this accepts and asserts. So exceptions and assertions.py. So what we really use are these things called these try except blocks for testing out code and being able to recognize and get these exceptions before they crash our program. So when we do try, everything within this try block right here, so tabbed over from this try colon, that's within this try block, we're going to test, right? We're going to see if it does anything funny. So in this case, we'll have an array with 4 positions, and we'll try to access the 5th position. So at a position that doesn't exist for this, or not an array, a list, a position that doesn't exist for this list. So we have indices 0, 1, 2, 3, and we're going to try to access position 5. Now, normally, this would just throw an index error, and we would automatically quit, right? But in this case, when we do this except index error, this says if within that try block you found an index error, instead of exiting the program, I want you to execute what's in this block. So in this case, instead of failing, we'll go ahead and just print index 5 does not exist. Now, we don't just have to capture a specific exception, we can also capture all exceptions. So we do this with just an except block that doesn't specify the exception we're capturing. So all other exceptions will go there. Now, if there's not an exception, we can have an else block. So this will just execute if we don't go into an except block. And then we also have a finally block. Now this will be executed no matter if we go into an except block or we go into the else block. Both of those will eventually lead to the finally block. So this is often used for some cleanup, right? So everyone will go into here. So if you need to do any program cleanup, it'll happen there. So let's take the case that maybe you want to keep track of how many successful and how many bad or how many successes and how many failures you've had on a specific try, except, else block. Well, maybe you want to say compare those two numbers every single time one happens, and you could put that in a finally. So no matter if you fail or you pass, you'll go into finally. Now let's see some other exceptions. Now these are all keywords in Python. So index error is a keyword that's reserved, and then same thing, there's name error. So let's say we want to print a variable that doesn't exist. So maybe we make a typo and we try to access a rat instead of array. So this will throw a name error. So instead of crashing, we'll just print out that variable doesn't exist. Now there may be incompatible types. So let's say we have the number 7, and maybe we're reading in from a file, but we forget to cast it as an integer. And instead it's still a string. So we can do an integer divided by a string. This isn't legal. These aren't valid types for that operation. So it'll throw a type error. So we'll catch that as well. So we'll print you can't divide an integer by a string. Now we can also check for a bad file with IO error. So we'll try to open a file that doesn't exist. Then we can try and use something that doesn't even exist. So just like we made a typo with a variable, if we try to access the append method for lists, and we try to call that on this array, and we accidentally make a typo and say append with an F instead of a D, well, we'll get an attribute error, so we can catch that as well. And we'll just print out we meant to use append. And then we can also try out, if we did bad conversion. So if we tried to take a big long string and convert it to an integer, this will give us a value error. So we can do an except on that as well. A fairly common one is also division by 0, like we mentioned earlier. Now let's think about this division by 0 error specifically for a moment. So we may run into a situation where instead of just printing out, or instead of just going past and just accepting it, going into an accept block and not crashing the program, maybe this is something where we really want to end the program. So we can manually raise an exception by using this raise keyword. So this raise, the specific type of error. So in this case, we'll raise a 0 division error. But we can also pass it a string. So instead of just getting a generic error message from the interpreter, instead we can give it our own custom message. And this is really important, especially when debugging or doing testing, where we can get more information or very specific information. So in this case, we can explicitly print out we can't divide 10 by 0, and we can print out whatever we wanted here. So we'll leave this commented out for now, just because this will exit the program, and we have a couple more things that we want to go over. So let's think about that idea of proactively, instead of reacting to errors, let's think about proactively preventing eventual errors. And we do that with asserts, and that's this concept of defensive programming. So we're preventing things, or we're being defensive instead of just waiting for bad things to happen and being reactive. So in this case, let's say we have an array grades, and let's say that we read a file, and the file is actually empty. So grades maybe never gets filled with data. So in this case, we can have an assert and say assert length of grades is not equal to 0. So in the case that this is equal to 0, this will equal 1, and then when we assert, this will equal 0. So it is equal to 0. And whenever we get a 0 on an assert, it will crash the program, right? So in this case, we do this assert, our condition. So we want to make sure that length of grades is not equal to 0. We want to make sure this condition is true. If it's true, we'll go ahead and say print the average. And so we can see where this gets tricky, or as far as where it gets useful rather, where if we're going to calculate an average, we need the length of that array, and if the length, or a length of that list. And when we take the length of that list and it happens to be 0, this would crash our program down here. But we can exit early up here with an assert if we can test if it's 0. So again, the format is going to be assert, then the condition we want to make sure is true, a comma, and then what we print out if it's not true. So let's go ahead and run this. So we'll call Python3 on accepts and asserts.py. So here we have all of the messages that we print. So unlike an if statement, when we have a, let's go ahead and open that file back up and go back near the top. So if we have an accept for a specific assert and then another accept statement that's a general one, both of these will get executed. So this, it's not like an if, else statement where only one will get executed. When it comes to these accept blocks, all of them will get executed that are valid. So we had an index error, and then we also just had an index error is a type of exception, and this block will capture all exceptions. So both of these actually get printed. So let's see, so we printed out index 5 doesn't exist. This will print in any case. The rest of them for if we had a value error or and then we also passed over our divide by 0 error. And then we have down here an assertion error, and our print message list of grades is empty. So again, we can be very specific and not just get a generic string that gets printed out if something was bad. So let's go back to down here at the very bottom where we said we could raise our own assertion. So let's check right here. So we can still raise an assertion if we want to using this raise. So inside of try, we may want to print out some information but still kill the program, and we can do that with this raise 0 division error. So let's run it again, and here we get our raised 0 division error. We do fail on that 0 division error, so we don't get all the way down to the assert. We fail on that last case when we called raise, and we printed out this string, right? So we can't divide 10 by 0. So again, we can be very explicit with our errors. We don't just rely on whatever the interpreter feels like printing out when the program crashes. We can give our own insightful information. So that's going to do it for today. This is a very common technique when it comes to testing and debugging in order to prevent errors and also make sure that you can handle errors. So if we go to github.com/coffeebeforearch, we've got all the program we use in this series. So we go to Python3 Crash Course, Fundamental Concepts, Test and Debug. Here's our handling exceptions.py. So feel free to download this, play around with it, try to understand this code. And if you have any questions, make sure to let me know. And feel free to send me suggestions on videos that you'd like. So as always, I'm Nick from Coffee Before Arch, and I hope you have a nice day.